So thank you very much for the invitation. So I will talk about Lagun. This is an open source platform for data exploration and optimization. This Lagun platform is jointly developed by Safran Tech and IFPEN at Geneva. So the context of this development is for the application. The application context is for data exploration for complex systems, where the data is very expensive to generate. So it ends up with small data and smart data. And our main applications are based on numerical simulations with high computational time. So the two main applications are the conception of complex systems and the calibration of simulators in order to predict and analyze the behavior of those complex systems. So a few applications in more details. First of all, we are often interested by analyzing the impact of the input variables of a black box simulator on the outputs by sensitivity analysis or uncertainty propagations. So just for instance, to rank the influence of the input variables to the outputs, or to only propagate the input uncertainties to the outputs. But as I said before, usually the simulators, the complex simulators we are dealing with are very expensive in terms of computational times. And we use some response surface or meta models to replace the outputs of the simulators by some approximated models. Another application is simulator calibration in order to reduce the uncertainty on the input variables. So we have in that context some experimental data at our disposals, and we want to determine the input variables that conduct to a minimal misfits between the simulated data and the experimental data. The third application is the optimal design, where we try to retrieve the values of the controllable variables, the design variables, in order to minimize, maximize, or respect some constraint on the outputs of the simulators. In practice, we are often faced to uncertain variables. For instance, for wind turbine conception, we have to take into account, of course, the environmental conditions, like the wind. And so we have some uncertain variables to take into account as inputs of the simulator. And in that case, we have to reformulate the formulation in order to take into account those variables. And of course, it ends up with a lot of calls to the simulators and expensive use of the simulators. And this is why we are using some meta models in order to limit this computational time. So in that context, we choose to develop a platform, Lagun. This platform it's based on R-Shiny language, and the idea behind this development is to offer easy access to the UQ and optimization algorithm to non-expert users. So Lagun is a web interface, web application. So there is a web interface to access to the algorithms, and we have already a lot of non-expert users, more than 500 in Safran IFPEN, and they can easily access to this platform by their favorite web browser. The simulators are running on remote computers or on clusters, And Lagun integrates some state-of-the-art algorithm via air packages. And we can easily integrate new packages thanks to the AirShiny interface. The improvements of Lagun are mainly driven by the end users. And we also try, of course, to integrate directly our internal R&D results in Lagun. So I will. Yes. First, I will give an overview of the history of Lagun. So the development started in 2019, and we are at the moment at the fourth release of Lagun, open source Lagun, of open source release of Lagun. So if you wonder what means Lagun, so Lagun is in Basque language, it means friend or companion. So I will give an overview of the workflow developed in Lagun and the different steps of this workflow. So as I said before, we are usually faced to very time-consuming simulators. So we want to use some response surface or meta models to limit this computational time. So the first things to do is then to construct a design of experiments in order to choose some input values to simulate to run the simulation. So the first thing is to define the input domain, so the dimension, the bounds, the type of variables, and then the idea, the goal of the design of experiments is to for a limited budget of simulation of points, we want to cover at best the domain, the input domains. So in Lagun, we have several methods to perform this design, to perform this step of choosing the input points, and we propose some interactive visualization to analyze this design of experiments. Then we have to run the simulations, or to run the real experiments. So we can do that outside of Lagun, or we can plug a simulator in Lagun in order to run those simulations with respect to the input variables, the input values selected by the design of experiments. So we can plug external simulators, scripts, executable. We have recently plugged bridge models to Lagun. So the first thing is to configure the simulator by this simple sheet. So we have to give the name of the executable, the input files necessary to run the simulations, and the output files. And then within Lagun, we have access to the list of configured simulators that you can select, and then we can monitor the runs of the simulation runs within Lagun. And here you see, for instance, the run associated to a design of experiment with DOE within Lagun. Then now we have the data set, so the input and the outputs of the simulator, and we can perform a preliminary exploration of this data set. So this is based on visualization tools, interactive visualization tool. So we can first just look at the simulated results by selecting different views in the input domains, or you can use some quite useful multidimensional visualization tool, the parallel plot, where you can select some range values of the outputs in order to see the correlation with the inputs. Then you can construct the metamodels. So in Lagun, we have several types of metamodel, from the simplest one, polynomial metamodels, to the most flexible one. Here it's the Kriging model or Gaussian process models. And then the user can run those different models on the different outputs of the simulator. So here you see 10 outputs of the simulators as column, and you see the different models on the lines. And you see the predictivity index for all those models, and the green color indicates a good predictivity, red color, bad predictivity. So the user can easily select the models, the good models, with this kind of global view of the metamodels results. And you can go further by selecting some models and compare them on the classical predicted value or true values plot. Now we have constructed the metamodels. We can perform now an intensive exploration assisted by the metamodels. So we can perform some sensitivity analysis, global sensitivity analysis, where we want to measure the impact of the inputs on each output of the simulators. And then you can, for instance, on this plot, you can see that some input variables, for instance, this one or this one or this one, are not impacting the output, whereas those two parameters, those two inputs, are impacting a lot the outputs. So. Another important point that can be important task that can be done in Lagun is the goal-oriented sensitivity analysis. In that case, you are not interested globally for the impact of the inputs on the output, but you are interested more on a given range of the output. For instance, for optimization, of course, if you want to minimize functions, what you want to measure is the impact of the inputs on the minimal values of this output. So we offer to the user the possibility to perform a goal-oriented sensitivity analysis, in that sense that you will restrict, in fact, the analysis to a small value of the output and see which input variables impacts those smallest value of the outputs. So the idea behind is to perhaps select some inputs to remove for the optimization and save some simulation times with this reduced number of variables in the optimization. Another exploration you can do based on the metamodel is to propagate the input uncertainties on the outputs. So this is quite classical, and you can also estimate the probability that a constraint for a given output is satisfied. For instance, here we would like to satisfy this constraint, so the output y1 smaller than the threshold equal to 10. So you would like to estimate the probability that this constraint is satisfied, and based on the simulation, on sampling using on the metamodels, you can have an estimation of this probability, and also by resampling you can have access to the estimation error for this computation. It can be also quite useful when you have some optimal design, robust optimal design problems to tackle. And you can, of course, you can also perform some optimization assisted by metamodels, so constraint or multi-objective optimization, or robust optimization with uncertainties. But sometimes you can afford to run some optimization based on simulator when your simulator is not too expensive, or when you have access to high computational facilities. And in that case, because as I said, with Lagun, you can plug some external simulators, you can run directly optimization of those simulators. So we have a facility in Lagun that to plug also external optimizers. So there is a default list of optimizer coupled with Lagun, but you can also plug your favorite external optimizer, and then run the optimization based on the simulator, and monitor the optimization iterations and simulation within Lagun. So follow for instance here, the decreasing of the objective function, and also look at the constraint satisfaction during the optimization iterations. So here you see, for instance, that the second constraint is active along the optimization process, whereas the two other constraints, this one and this one, is always satisfied during the optimization. Okay, so I briefly introduce Lagun. So do not hesitate to go to the website to download Lagun and try to run it with your favorite bridge model. There are some ongoing developments on the workflow backups, and also as we did for the optimizer, the plug of external metamodels or response surface. And do not hesitate to contact me if you have any questions, or if you want to contribute to this open source platform development.